Hello, my name is Evan Schwartz. We're going to take a look at BattleCry, What Went Right. Some of the areas, topic-wise, that we're going to look at is the design and aesthetics, the game design document. That's going to be one of the critical pieces, in my opinion, that really kind of set the tone for everything that did go right in the environment. That's going to dovetail nicely into some of the architecture design, particularly around Azure SQL services, the way that we design the SQL services, the store procedures, and the data. Then we'll take a little bit of a look at SQL directly, how we're managing the web service layer for RESTful services, and just some of the code gains and wins around that. We'll take a look at how we manage the project using the tool, and the Underdog portal was a huge key aspect to success on this project. I'm fairly certain that wouldn't have happened or we wouldn't have been nearly as successful had we not had that development project tool. And after looking through the development, we'll look at some of the key mechanics, particularly around the voice mechanic and the visual debugger that was put into place early to be able to dig in and analyze the BattleCry, which is the main mechanic for the game. So let's take a quick look at that, and then we'll end up with a discussion around testing and how that really kind of came together to drive it. But let's start with the game design document. So one of the things, having been a part of several projects throughout my stoic career, as it would be, is that to see projects sort of veer off track. Now, sometimes they veer off track because they need to, and sometimes they veer off track. And if they need to, that's a really good, strong indicator that maybe we didn't spend enough time in the design phase, designing out what we think the program is supposed to do, what the goals and objectives are, and that sort of thing. So one of the things that I consider went right is if you go through the game design document for BattleCry, and you look at its use case diagrams, you look at its flow diagrams, and you really kind of study through it, and particularly around the prototype screens, right? We are so very close to the design that you could almost say we hit the nail on the head. Now, there's definitely some design changes that we want to do, but as far as being able to have built to the design, to the spec that was presented, we're very, very close to what was originally designed. To me, that ability to take the time up front and stroke your chin and think about things and really put together a lot of thought into a design, and then see that design manifest and see that you are very close. Once you're there, that kind of gives you a sense that you've put the appropriate amount of time and energy into your upfront design. Now, I've never been on a project that was 100% hit. I'm not saying they're not out there. I'm just saying I've never been on one. So as I go through and I'm just sort of speeding through the game design document, to me, this was one of the successes. We're right there on the game. We are literally each one of these parts and pieces, maybe not 100% spot on looking the way it was from the prototype, but I wouldn't expect that, right? So the designs around the milestones, how we're putting it together, what is it generally going to look like? What are the capabilities of the game? How is combat going to work? All of these things were close enough that any deviation from them that we had to do was minor and had a minor impact on the project and the project's timeline. So to me, this was a huge key and thing that went right, that I think a lot of projects tend to overlook is the upfront time. Everyone's excited to jump in and start getting things working. But for me, being a one-man show on this project and putting really such a large goal in front of me, I wanted an end-to-end game where, generally speaking, these weren't just prototype levels. These weren't just a handful of sample levels. I wanted a whole game. Is there going to be more buffs? Are there going to be more heroes? Yeah, I can add more content to it. But as far as feature end to end, I wanted everything there. And that was a tall order, right? And one of the critical pieces that I had to spend a lot of time thinking about and designing, which is evident in this game design document, is how is a one-person show going to do all of this? So everything that sort of spawns off the game design document has that undercurrent of, okay, you're about to design out the entire data model. You're one man. So how are you going to do that, maintain that, and then be able to feed your web services layer, and then your web services layer is feeding your calling UI, and then you're calling UI. I mean, that's a lot of different systems that are normally handled by a lot of different folks, and now you've got just you to do it. So keep that in mind. Don't get too lofty on your ideas. Sometimes you have to make some compromises on architecture, but the reality is keep that ever present in your mind that whatever you're trying to do, you're the only guy that's going to be doing it. So to basically break into that, let's take a look at our team viewer session here. So what I'm doing here is I'm team viewing over into my other development workstation, which runs SQL Server Management Studio, not available on the Mac, and just makes it a little bit easier to view. So one of the things to firstly note is intentionally there are very few tables, right? It comes back to one guy, right? One guy's got to maintenance this. If I build out this 30, 40 table structure, it can get out of control on me really quickly. But to facilitate that, I created what I call pressure relief valves, just areas where I know that the design needs to be a little flexible. And in those areas, I use XML. And to basically give a screenshot of that. So if I pull up my battles and I can see all of my battle records in here, I can also see that my game board is XML. And one of the advantages to XML for me is that if I needed to add an additional property here, I can do that without breaking anything. So I can evolve this game board as I need to, as the pressures of code or the confining parameters of architecture start to put downward pressure on the design. The design's flexible enough to push back without breaking everything. So that's a critical piece. And again, here on the Barbarian update itself, as I want to track and collect things, I can throw this into XML and store it in the table. And that sort of gives me a jagged record design, allows me to be very flexible on how I'm storing this information. Again, is this the most efficient architecture? Absolutely not. A fully well-formed database is the most successful architecture. But that's assuming I know everything up front and there's not going to be any changes. And there's always risk for change in a project. So, and based on the number of resources I had, this was a decision made from the game design document, implemented and realized in the game. That was a very successful architecture, in my humble opinion. So the next piece is getting data into and out of this database. So using these stored procedures abstracts my service layer as well as my end game away from the data model. It doesn't know anything about these columns, or these columns, if they are the same, are incidental. Because the only thing that the web service layer knows anything about is store procedures. Read service, write service. I want to read, update, just standard CRUD-based stuff. To make that even simpler is every store procedure follows the exact same prototype. It has one parameter. So as we look down these, you'll see the prototypes are identical. They all have one parameter. So I don't have to worry about breaking any code upstream or downstream because I need to add more data going into or as parameters or criteria into a store procedure. Everything goes into this XML. And as the XML is broken out into the parameters the store procedure needs, the store procedure deals with those as needed, right? So if, and to give you a better example of one, here's one with a lot more conditional logic. Same prototype, this is getting the games, but once it pulls out the parameters it needs, it conditions its flow. Right, so it's a little piece of code. So if it's not null, then I'm running this. If it is null, then I'm running this section of code down here. That brings an entire host of benefits to the application. I can version protect my store procedures. So if I wanted to, one of those parameters could be a version. So if I'm upgrading from a 2.0 from a 1.0, the same set of store procedures could service my 1.0 calls, and if the version comes in 2.0, a code pass and goes down a different way. And again, the whole principle behind that is so that I'm not breaking a lot of code, right? There's a lot of code that hangs off and manages these store procedures and expects certain things. I can maintain that contract while developing a new contract with all the same piping. So again, it's just a force multiplier. One of the other requirements is that every one of the stored procedures has a try catch, and I output into this error log. Again, at this layer, the SQL layer, the error log was a huge force multiplier for me. Being able to select into my error log and see, okay, this is the error that SQL is providing. I don't always have to show that to my user. I can just capture it passively, see that there's behavior problems in the UI, and then come into here and find out exactly what it is. And then I can pull up the XML. This is exactly what was passed into the procedure. So I can take this exact string and rerun the store procedure with that exact same data and see the error for myself at the query analyzer and start to step trace through using Visual Studios to find out what's wrong with the store procedure. That to me is a force multiplier, that this is passively collecting error data for me against all of the players that are playing. So as I get reports, the user story is important, but being able to dig in and see the exact error at the exact time with the data they used to cause that error and then be able to recreate it consistently and repeatably, that's a huge force multiplier for me. There's always going to be bugs. There's always going to be errors. So whenever I'm designing anything, it's always from the position of what happens when it breaks. So the error log is a huge win for me, and the architecture around the stored procedures is a huge win for me. So that's the SQL layer, kind of in a nutshell. Let's take a quick gander at the Azure Services that's behind it. So Microsoft Azure is really a beautiful architecture. I mean, it's a lot to take in. Don't get me wrong. So right here I'm looking at my maintenance job on my scheduler. Let me go back to my home. Let's go to my dashboard. So what I've developed here is I've got my app service. So these are my web services here. And I've got my SQL Server and my database. So this is really one component, which is the SQL Server, which we just saw. I've got my daily maintenance scheduler job. And then this is my app service plan. So this is just part of the subscription. So under my app services, this is where I'm hosting all of my web services. And one of the things I liked about it, and let me go ahead and pull that. So in the project, this is what an Azure App Services looks like. And for all intents and purposes, this is an MVC. That's all this really is. So this is just a RESTful service, a get, a put, and a post. Nothing major there. But very similar to the stored procedures, you're seeing that same consistency of architecture here, where I'm creating my criteria object, I'm passing in the parameters into my XML, and then I'm calling the stored procedure. I'm getting my data set back, I'm loading up my objects, and then I'm returning JSON, right? So everything falls within that same category. I have default. I can always count on every one of my stored procedures, no matter what they're doing, to return an error code and error message, which means that I can create at the minimum a calling service to be able to get that data back. And that's why we see such a consistent development of this code, right? I'm essentially just creating my data handler, calling my data set, and entering on my data set, and then returning the values, right? Very easy. So building this out was not very complicated. And having few tables, and I have few services and some architecture. I've got my maintenance controller, my players controller, the values controller is essentially my game, and then the cries themselves. So that creates what I would consider a very lightweight piping tool that's able to take in the data. I'm intentionally minimizing the business logic at these layers, right? So that's another part of the architecture that's helped out. And it allows me to move to the edges, which I call edge-based development. I work at the data layer, and then I work at the UI layer. I try to contain business logic and things of that nature at the data layer where possible, and I try to contain UI logic and presentation logic at the UI layer. And all of this piping in between is just that, just ways to move data back and forth in a controlled fashion. Now, one of the other things that was key to Azure that made this work is the ability to basically deploy this. So let me walk. And then what this does is this goes about its business, and it'll package everything up. It'll communicate with Azure. It'll push the web services out to Azure, and then it'll get everything pushed into production and spin it up. I get source control out of the deal. I get a fairly straightforward deployment. But the point of it is it's really simple to deploy. So all of these things, the the design around the game design document, the architecture around the SQL layer, the implementation through Azure, all have led to force multipliers to giving me maximum velocity at development. Okay, and having the ability to spin up these services, something even as simple as the maintenance service, was key to the success of BattleCry, in my humble opinion. So that's the Azure piece. Um, all of that force multiplying and that ability to have velocity into the project all leads into well managed project. Even though one man, having these tools at my availability, mission critical for the success of the project. Having Underdog, the ability to maintain release files, having the ability to store and manage my documentation. One of the things I did a lot is I traveled a lot due to my work. If I didn't have this portal, I would not have completed this course. This portal allowed me to stage all of my documents, keep up with my tasks, have milestone by milestone. Early on, I was keeping backlog on a separate list. Said, forget it, I can't do that. That's too much for me to have to maintain two lists. Let me throw it in here as its own milestone, and then I can cherry pick those tasks out of backlog and feed them into my various milestones to get each one of those completed. And it created that cadence for me that, okay, this is milestone 7. This is what I got to get done. This is a task. Work, 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 work. And if it wasn't for this well-planned, again, rooting from the game design document, right? This success begets success. So as we're seeing that the game design and the thought behind the game design is creating successes in architecture and is now creating success in the way that the system that was designed was implemented at Azure, and we're now seeing it's creating success in the project management tools, which are creating even more success to the completion of this project, and without which I just don't think we could have got. So we'll move into a particular code success. The key mechanic of the game is the BattleCry, right? So having the ability to make sure from a code perspective that we're doing what we need to do was key. And early on, we didn't have that in place, but as we got to a point where clearly the BattleCry is impacting, we developed a visual debugger, a way to get into the system and be able to see what the BattleCry is doing. Is it calculating the way we want? Is the calculator doing what we want it to do? And if so, how is it doing it? So I'm just going to go through this real quick, and I'm going to just create a quick BattleCry. So bear with me. Bah, bah, bah. All right, so right off the bat, being able to see the results from your BattleCry from a player and see the FFT transformation. We're going to make some additional changes and put some numbers in there so it's more meaningful to the player. But coming into the game itself, let's focus in on that. So as we'll zoom out a little bit. So I've got them all stacked over each other. So let me spread these out a little bit. Take infantry and pull them up a little bit. So if you were to put these end to end, you would be looking at essentially the audio track that we just saw. So on infantry, for instance, let me shrink this down. The result was 540. That's how many infantry we summoned. And 781 was the particular note as it went through the FTT from a magnitude over time perspective that really kind of stuck out. So we're going to go into that area, 581, or 781, excuse me. So let's dig down, 781, that's this guy right here. So I'm going to dig up my handy dandy calculator and just sort of go through the BattleCry calculation, which is 0.027000841, and I'm going to multiply that by 1,000, which gives me 27.00, and then multiply that by 20, which gives me 540.016. So if I scroll back up and I look at the results, 540 is the result. So from this system, I'm able to compare directly and then zoom in and inspect the FFT and the audio wave to kind of get a sense of where I think this thing is. Is it doing what I expect it to do? I'm suspecting that the 781 is probably right about there. And this is giving me sort of just a visual confirmation that what I expected it to do, how it's running the calculations, is confirmable. I can really get down to the granular uh, sample itself, run the formula myself, and generate the same results that it's completing. And I can do that on each and every piece of the sound wave. So whether it's the the cavalry piece or it's the archer piece, they all have the same object here that allows me to kind of dig in. And then as tertiary benefits, I can actually see the audio wave in the game itself. So that's sort of the visual debugger. That gave us a lot of confidence that things were working out the way that I wanted them to work out. The last piece I want to kind of cover is the usability testing. We did testing throughout the entire program, but essentially the usability testing was the one that cracked the code on a couple of critical areas, particularly around the list management and around the way that battle is conducted, the mechanic around the battle, and how the user interfaces with combat. And to really make that stand out, right, we saw the testing time and time again, putting in the user, doing the standard recording and watching and getting feedback. But being able to overlay some quantitative data from the PES scores and the NASA TLX surveys and really kind of hone in on where are the areas that the user is struggling with and what are some potential solutions. It didn't really come around to solving the problems, but it put enough of a magnifying glass on those two areas that as we go forward to implement the fixes, it's really going to take BattleCry from, yeah, it's pretty good, it's at this level, it does what it says it's going to do, to that next wow factor of here's a game someone can just get into and stumble around and learn and play and enjoy. So to me, the usability experience on the project and going through that exercise was a huge, we got it right. Being able to collect the data, put it in front of people, record how they're playing in the game, and then overlay those two sets of data is what really kind of magnified not only the problem, but hinted quite a bit at what the solution was by taking the qualitative results and overlaying on top of the quantitative results. Okay, thank you.